Maths class. Today we are going to start a new lesson, that is circles. You already know that what is meant by a circle. One point will be there. From that point, from this point, all these points have equal distances. That central point is known as the center of the circle, like that. From the center, we are taking one point on the circle. This is known as the OA is known as the radius of the circle. From center to any point, length of the line segment from the center to any point on the circle is known as the radius of the circle. Then PQ is the line that is passing through the center of the circle, that is known as the diameter of the circle. Diameter means 2 into radius, you will get the diameter of the circle, because OQ is same as OA, then OP also the radius. So 2 times radius is equal to diameter of the circle. Then MN I have taken, that is 2 points on the circle and we are drawing a line segment, that is known as the chord of the circle. The line segment joining any point on the circle is known as the chord of the circle. MN is a chord, OA is the radius, PQ is the diameter. The longest chord of the circle is known as the diameter. Diameter also a chord, because but it is passing through the center of the circle. So it is the longest chord of the circle is the diameter. Here MN is the chord of the circle. These are all things you already studied. Next up, we are taking one small part of a circle. Like that we are taking x1 is a small piece of a circle, that is known as the minor arc. Normally a part of a circle is known as the arc. This smaller one is known as the minor arc. Major one is known as the major arc. The remaining part will be the bigger arc, that is known as the major arc. Next one is major sector and minor sector. What is meant by sector of a circle? Do you how we are cutting a cake? Do you know the cake pieces? Cake pieces in the shape of a sector. Thus I am taking radius AB. What is OA and OB? OA and OB are the radius of the circle. Then AB is an arc of a circle. The space between two radii and arc of a circle is known as the sector of the circle. Here smaller one is known as this OAB. That will be the minor sector, and the bigger one is known as the remaining part. If you are taking again AB, the bigger one is known as the major sector of the circle. Sector means the space between two radii and arc of a circle. Next I am discussing about segment of a circle. This is the segment, this part. If you are shading, this is the segment, and here this part is the sector. This will be the minor sector, the remaining one will be the bigger one will be the major sector. Segment means what is PQ? PQ is the chord of a circle, and this part I am taking here as PSR. PSQ is an arc of a circle. So the space between a chord and arc of a circle is known as the segment of the circle. Once again, the space between the chord and arc of a circle is known as the segment. The space between two radii and arc of a circle is known as the sector. The smaller one is known as the minor segment, and the remaining bigger part is known as the major segment of the circle. These are mainly about the circles. Next, inside the circle, this is known as the interior of the circle. Interior of the circle, inside of the circle. Then this will be on the circle. On the circle. And this outside part, this will be the exterior of the circle. Exterior part. Interior means inside the circle, and if that line what you are drawing, that is known as the on the circle. On the circle and outside of the circle together known as the exterior part of the circle. Then, what is mean by circumference of the circle? What is the total length of this? The boundary line's total length, that is known as the circumference of the circle. What is the total length we have drawn? That is known as the perimeter or circumference of the circle. That you already know that 2 pi r is the perimeter or circumference of the circle. Area of the circle is pi r square. Then center of the circle lie on the interior of the circle. That you know that. Here will be the center. Center lies on the interior of the circle. Next we are discussing one theorem. Equal chords of a circle subtend equal angles at the center. Subtends means makes. Two equal chords are there that makes equal angles at the center. AB and CD are the two equal chords. And what will be that chord making angles? AOB is the angle made by the chord AB and COD is the angle made by the chord CD at the center O. You want to prove that angle AOB is equal to angle COD. That means equal chords make equal angles at the center. For this, first proof, we want to what all things are given that you want to write first. AB and CD are two equal chords of a circle with center O. You want to prove that angle AOB, this angle AOB equal to angle COD. These two angles are equal A. You want to prove. For this, in triangles AOB and in triangle COD, here also we are using concurrency of the two triangles. Then by CPCT we will show that two angles are equal. In triangle AOB and in triangle COD, OA is equal to OC. What will be the reason? OA equal to OC. The reason is radius of the circle. Again, OB is equal to OD. OB equal to OD. That also radius of the circle. Then AB equal to CD. That they already given two equal chords. So AB equal to CD given. Then which concurrency here using? So triangle AOB concurrent to triangle COD by SSS concurrence rule. Then you want to show that this angle. So angle AOB equal to angle COD by CPCT, and you want to conclude that so equal chords of a circle make equal angles with the center. Then how we can say this converse of this theorem? If two chords make equal angles at the center, the chords will be equal. Sometimes that also will ask. Once again, if two chords make equal angles at the center, the chords will be equal. That will be the converse of this theorem. That also we can prove the same way. Here, how we can prove that? Just look. Here, what they have given equal angles. So, angle AOB equal to angle COD already given. But you want to show that AB equal to CD. Then how we can show that OA equal to OC. Then OB equal to OD. The reason is radius of the circle. Then angle AOB is equal to angle COD. That also given because two chords make equal angles. Already they are given. Then two sides and including angle. So these two triangle AOB concurrent to triangle COD by SAS concurrence rule. Then we can write that AB equal to CD by CPCT. So if two chords make equal angles at the center, the chords will be equal. That also we can prove by the same concurrency rule. Next question. The perpendicular from the center of a circle to a chord bisect the chord. Next theorem. One chord is given, PQ is the chord here, and we are drawing from the center one perpendicular line to the chord. That line will bisect the chord. The bisect means it will make the chord to equal parts. That means PM will be PM equal to QM. Thus, also a theorem. Actually, proof is not given in the textbook, but we can prove this using the same concurrency rule. This and all are useful for the 10th classes also. While proving exercise question, we need this is an important result. Then, how we can prove this? Just we can join OP and OQ. Join OP and OQ. Join that. Then we will get two triangles OMP and OMQ. Then in that two triangles we know that OP is equal to OQ. What will be the reason? Radius of the circle. Then OM is equal to OM, common. Equal to common. Then angle OMP is equal to angle OMQ is equal to 90 degree. Then you got this. So OM is equal to OM, OP is equal to, then we can say that these two triangles are concurrent by RHS concurrence rule. So OP is the hypotenuse, here OQ, then one side OM is equal to OM, you got at one angle is 90 degree. So we can say that triangle OMP concurrent to triangle OMQ by RHS concurrence rule. By RHS concurrence rule, then we can write PM is equal to QM by CPCT. Corresponding part, just look here, PM, here QM. PM is equal to QM by CPCT. So we can say that the perpendicular from the center to the chord of a circle bisect the chord. Okay. Next theorem, the line drawn through the center of a circle. The same, the line drawn through the center of a circle to bisect a chord. Here, previous question, they told that the line, perpendicular line drawn from the center of a circle bisect the chord. But here given, the line drawn through the center of a circle to bisect the chord. So here given, PM is equal to QM already given. Because this line bisect the chord, so that drawn line is perpendicular to the chord. Here you want to show that this angle is 90 degree. Angle OMP is equal to angle OMQ is equal to 90 degree you want to show. For this also we can join OP and OQ. Then in the triangle OMP and OMQ we can write that OP is equal to OQ, radius of the circle. Then OM is equal to OM, common. Then here they already told that this line bisect the chord. Then we can write PM is equal to QM. That is given. So these two triangle OMP concurrent to triangle OMQ by SSS concurrence rule. Then angle OMP equal to angle OMQ by CPCT. Now you got these two triangles are equal, but you want to show that perpendicular to the chord, this line. So angle OMP is equal to angle OMQ is equal to 90 degree. You want to show that. How we can show that? You know that this is a straight line. These two angles will be linear pair. So sum of that two angles will be 180 degree. And you got these two angles are equal. So each angle will be 90 degree. So the drawn line will be perpendicular to the chord. Next we write that angle OMP plus angle OMQ is equal to 180 degree linear pair. The reason is linear pair. From these two equations, here 1 I am giving, here 2. From 1 and 2, first we got that two angles are equal. Then second step you got that two, sum will be 180 degree. So you will get each angle will be OMP is equal to angle OMQ is equal to 90 degree. So the drawn line will be perpendicular. That line is bisecting the chord. Next theorem, equal chords of a circle are equidistant from the center. First what we studied, equal chord of a circle, equal chords of a circle make equal angles at the center. Otherwise, if two chords make equal angle at the center, that chords will be equal. Next one, two chords are equal. AB and CD are the two equal chords. They are equidistant from the center. Then OL is the distance of that chord from the center. Here OM is the distance of that chord from the center. So that also will be equal. Here proof is not given. No need of studying. Just you want to study this theorem. The AB and CD are two equal chords. The OL and OM are the distances of that chord from the center. Then OL will be equal to OM. Then next we are discussing about the converse of that theorem. That is, chords equidistant from the center. Two chords are given, that is OL equal to OM is given. Then that two chords will be equal. Then first case we studied that equal chord AB equal to CD, they are given. You want to show that OL equal to OM. So that means equal chord of a circle are equidistant from the center of a circle. Next one, two chords are there. They are equidistant from the center given. Then the chords will be equal. These are the another two theorems. Proof is not needed. Just you want to study this.